Hi there, welcome to my channel. In this video, I'm going to discuss about the solution for removing duplicates from sorted array. Let's look at the problem description. We are given an integer array nums and sorted in non-decreasing order, and we have to remove the duplicates in that array in place such that each unique element appears only once, and also the relative order of the element should be kept the same. And finally, we have to return the number of unique elements in the nums array. Let's look at example 1. So the input nums array has 3 elements 1, 1, 2. 1 has a duplicate, so we have to update this array such a way that the duplicates are removed and only the unique numbers are present in the beginning. So in this case, in the place of this 1, we have to write 2, and we have to return the number of unique elements, which is 2. And in the case of example 2, we have 0 has duplicates, 1 has duplicates, 2 has duplicates, 3 has duplicates, and 4 do not have any duplicate. So in this case, we have final output array should have only 1 0, 1 1, 1 2, 1 3, and 1 4. Totally 5 unique elements in the output array. And the constraints for this problem are the array length is ranging from 1 to 30,000. And the value of the numbers will be ranging from -100 to 100. The nums array is sorted in non-decreasing order. Let's look at the approach to solve this problem. So we are given this input array which has 3 elements 1, 1, 2, and the expected output is an array with 2 elements and 1, 2. We can solve this problem using two-pointer approach. So we maintain one read pointer and one write pointer. Okay, both points to the second element in the array. So using the read pointer, we traverse the rest of the elements in the array. Okay, as we traverse, we compare the value pointed by the read pointer and its previous neighbor. Okay, if they are not equal, then element pointed by the read index will be copied to the location pointed by the write index, and then we have to increment the write index. So we repeat this process until we traverse all the elements using the read pointer. So when we complete the traversal, the write index will give us the total number of unique elements present in the output array. So that's what I have written here. So initialize the count to length of the input array, and then initialize read index and write index to 1, and traverse the elements in the array using the read pointer. And in each iteration, if the elements at the read index and its previous neighbor are not same, then copy the element at location read idx to the location write idx. Then increment the write idx. Once this traversal is done, then finally we return the write index. Let's look at the flowchart. Input for this procedure is nums array, and first we initialize the read and write indexes with value 1, and initialize the count variable with the length of the input array. Okay, then we are entering the for loop, and we check whether we processed all the elements in the array. If so, we return the write index value. Otherwise, we check whether the value pointed by the read index and its previous neighbor are same. If they are not same, then we have to copy the value pointed by the read index at a location pointed by the write index. Then increment the write index, and we increment the read index regardless whether they are matching or not, so that we process the next element in the array. We repeat this until we reach the last element. Then finally we come out and return the write index. Let's move on to coding. First I initialize the count variable with the length of the input array. Then I initialize the write index with value 1 so that it points to the second element in the array. Then I write the for loop. So here the read index is initialized with value 1. So it also points to the same location where the write index is pointing. Each iteration, I compare the value pointed by the read index and its previous neighbor. If they are not equal, If they are not equal, then I copy the value pointed by the read index into the location pointed by the write index. Then I increment the write index, and finally I return the write index value. Next I'm going to run the test cases. All the tests passed. Next I'm going to submit this program. Cool, this program is accepted. Next I'm going to do the code walkthrough with sample input. We are given input array nums with 3 elements 1, 1 and 2, and we have to return the number of unique elements in that array, which is 2. So the expected output is 2. First we initialize the count with the length of the input array. So the count is initialized with 3, and the read and write indexes are pointing to the second element in the input array. Okay. Next we enter the for loop, and the iteration 0, both read and write index point to the second element in the array. So first we check whether the element pointed by the read index and its previous neighbor are not equal. So in this case both are equal, so we are not doing any processing here, and then we increment the read index so that we go ahead and process the next element in the array. Okay, so that's why when we leave the iteration 0, the read index becomes 2, so it points to 2. And in the iteration 1, we compare the value pointed by the read index and its previous neighbor. They are not equal, so we copy the value pointed by the read pointer into the location pointed by the write index. So that's why that 1 becomes 2, and then we increment the write index, so the write index becomes 2, and then read index becomes 3. Okay, because it reaches the end of the array, we come out of the loop and then we return the write index, which is 2, and that is an expected output. Next I'm going to do the time and space complexity analysis for this solution. The time complexity of this solution is order of n. So basically this for loop, starting from index 1, it traverses the rest of the elements in the input array. So in this case, for this case 1, the nums array has 3 elements. So this for loop performs 2 iterations. If there are n elements, this for loop will run for n minus 1 iterations. So the time complexity is order of n. The space complexity is order of 1 because we are not allocating any additional space in this procedure. So the space complexity is order of 1. Thanks for watching this video. Have a great day.